DemoWare, and gamers do rest. Actually, they don't. As you can see from one of our recent graphs, it doesn't even come close to zero ever. And these guys get really excited when it's close to lunchtime. We're an Activision Blizzard owned subsidiary. Our main offices are in Dublin. We also have offices in Vancouver and in Shanghai. So we cover approximately all time zones. So what we do, this can basically be summed up straight from our recruiting book. We enable gamers to find one another and shoot each other in the face. We provide services like leaderboards, matchmaking, anti-cheat, accounts management, and more to Activision game studios. Last time I checked, we've had 70 plus services that are actively developed and maintained. And the big game we support, of course, you all know, Call of Duty. Of course, we're hiring. So if you're interested in what I'll show you, come talk to me afterwards. So why REST? Firstly, interoperability. Our APIs must be available to game clients, companion apps, websites, and by using the right protocol, HTTP in our case, and REST principles, we can achieve a level of interoperability that other architectures can. Second of all, scalability. From all architectures I come across, REST seems like the one truly web scale. Basically, you can look at the web as a huge REST API, and your browser is the client that consumes it. So you have your entry point, your bookmark, you have HTTP verbs to lock the web pages. You use links to navigate to other resources. You have URIs for that define resources. And your browser interface interprets that resource based on hypertext metadata. So I think it's safe to say that using RESTful architecture will make your services easier to scale in the long run. So, DemonWare has a lot of services, and we use a lot of different tech. So I'm going to focus on what my team uses for building REST APIs. So we have Python, Django, MySQL all on top of CentOS, Apache, and ModWhiskey. As you can see, we don't use anything flashy. Our REST is simple, reliable, and easily scalable. Our projects are built from the start with sharding in mind. We don't need specialists to deal with exotic tech, and this simple layout saves us from tech stack related issues most of the times, and lets us focus on solving business problems. Also, reliability is something we really take seriously. As you can see, when we compare our game launches to other game studios launches. So, anyone who ever built an API probably heard of Roy-Fielding's thesis. It's a long read, but when you're finished with it, you are left astonished by the elegant concepts. You want to live those concepts, and in most cases, you will succeed. But then the real world kicks in, and whatever you do, your clients will misuse or otherwise perfect creation. So, in the gaming industry, things get more complicated. You have custom protocols because everyone has to do their thing. You have mandatory libraries and SDKs. You have multiple languages and platforms, C#, .NET, Java, you name it. And documentation goes from OK to non-existent. So basically, you build stuff by talking to the developers that build them. Most game developers have little to no contact to web services for most of their careers, so little end user education is needed for even simple things like what JSON is, what do HTTP status codes mean, or how to use query strings. Yeah. Only in recent years the industry started to embrace HTTP and build REST-like services that can be used without too much effort. Having said that, our API is RESTful. I want to say yes, but even I have to admit that we do not adhere to all the principles, either because of business constraints, legacy logic, or backwards compatibility. The important thing is that we're moving in that direction, and we're encouraging our clients to follow suit one step at a time. Here's a basic example of the things we use design-wise. We have version in the URL, we use camel case in JSON, and also in query strings. Not in Python though, we don't have a contour variables. And we use standardized links, and of course it's Marine code. So just using REST is not enough to run your services at scale. You need to have the right processes and tools in place. So I'm going to walk you through how we do it in demo. We use Git and GitHub Enterprise to manage our code. We use branches for features and fixes. Master is always deployable. We use pull requests to review our code with our teammates. And when everyone is happy and the changes and our build is green, after all the tests pass, we tag it, and we ship it. As you see, we use RPM for packages, and I'm not going to expand on this. Python packaging is a dedicated subject. All I have to say, we're not a Python-only shop, and we have to keep our packaging consistent across all the company, and also SRC for some reason. This is how our config file looks like. So why YAML? Well, cross-project. As I said, we're not a Python-only shop, so we have to keep our configurations files consistent. YAML is just as readable and diffable as Python code. So from the point of view of people reviewing it that are not Python developers, it's fine. And validation. So we dynamically build the Django setting module to involve the YAML file. So at that point, we check for missing configs or invalid configs. And this helps us find if something is misconfigured quickly, not when the actual config is used in the app. This is an example of one of our validation configs. As you can see, it's pretty straightforward. We have a type of validation, default, and description. So in this case, image has to be greater than 0. On the subject of validation, we also validate data sent by our clients. And for this, we use JSON schema. As you can see in this example, we can do all sorts of fun stuff with it. This is quite cool. Restrict by type, use pattern for regex pattern matching. We have minimum or maximum values for integers, minimum maximum values for strings, and required fields. And we can also define what kind of exceptions are raised when, in certain contexts, required type. We can also have a list of acceptable values. The cool part about this is that you have all the validation of the resource you're receiving in one place. You can see at a glance all the validation conditions. Just one thing to mention here, we don't do any heavy business logic validation at this point. It is possible, but it gets messy and it defeats the purpose of readability of this schema validation. Here's where Django middleware shines. In your views, just raise the exception and the middleware catches it in the process exception. Then after you catch it, you can render it in the HTTP response and send it back to the client to get something like this. You might have to make adjustments depending on how you raise your exceptions, but that is basically as you can see, we also have a hierarchical approach to our error codes and errors. This makes it easier for us in debugging and both for the client. We relay our logs with the help of syslog to our in-house aggregator built open source tools. In the end, we get something like this. Things are somewhat noisy, but once in a while, you get this, and you know you have to do something about it. Of course, you don't spend all day looking at this. It is the purpose. And we have alerts to notify us when this happens. But this graph can give you an overview of the frequency of the errors that are happening, and also the time frame when it happened. So you can, it helps you a lot in debugging certain issues. When we format our logs, we try to keep the needs of production in mind as opposed to development. The messages should be concise, complete, and contain context. Speak about it this way: if you were to put a log result in a bug ticket, would you understand where and why the issue occurred? And here's a simple example. We have a level project, because our aggregates logs from multiple projects. We have to have a separate project, the app, view, client, and of course the message. Besides our logging, we've got a metrics. So all our metrics are sent to an in-house aggregator that verifies and sorts the metrics, and then sends them to Graphite. So this is generated by Graphite. What's the difference between logging and metrics, and how they help us? Well, you can, with metrics, you get different information about your app, like, say, mail sent or fails, SQL query times, slayback, app response times. And you notice anomalies like this right away. Again, Django really helps here, and we get in effortless metrics. As you can see, when we process the request, we record the time. In the process of the response, we do a difference and send the metric away. We can also add a process exception here and do metrics for exceptions. That's pretty sweet. For authorization and authentication, we use JSON web tokens. In simple terms, JSON web tokens contain claims that allow a system to access resources it owns. We use an in-house library called Jose that we open source to securely transfer these claims within our system. And you can view the code in GitHub, and also you can take it for a spin just with this stuff. Summary. The rest is awesome. Use as many concepts as you can, but be pragmatic in your approach. Monitor everything. Error logging and metrics are what makes scaling survivable, and work hard. Thank you.